Okay, good morning, students. How are you all? I hope that you are all fine. Okay, now I'm going to teach you the chapter in physics, that is motion. And motion and rest both are the quite opposite terms. So we'll say that, uh, and for suppose one body is here. For one body, for another body, this may be at rest, and for some other body this may be is in motion. Okay, I'll tell you one thing. And suppose this is the house, this is your house, and the next by this is your friend house. And now one more friend, he is moving on a car from like this, from this side to this side. So you are here, this is your house, and for your friend, this friend, let me name here B, and this is C. For your friend B, you are at rest, but for your friend C, you are not at rest. And while this is moving here, for him, it seems that it is also moving in the opposite direction. Opposite direction. The same object for two different persons, it is two different perspectives. One is at rest and one is in motion. This is to say a particular body is at rest or in motion, we need a frame of reference. Frame of reference in the sense reference point is this is the friend B is a reference point and friend C is a reference point. And suppose while traveling here, you may observe that while traveling, you may observe that there are many trees on the roadside. They travel in opposite direction to you. Opposite direction to you. Okay, actually, the person who is standing on the road, and for that person, the trees are at rest. But for you, who you are moving in a bus, and the tree is in motion, opposite direction. So this is the two different scenarios about rest and motion. And now next one, suppose if a person is moving from here, so uh, okay, and this is 4 meters you walk from here to here, and from here to here again you walk. And let me name it here, from A to B you moved, and from B to C, and this is your initial position and this is your final position, and this is the target, and you are traveling from your home to school, let us say home to school to reach. And this is, for example, I am taking for simplicity of calculation, this is 4 meter and this is the 3 meter. Okay, in this particular case, I want to discuss distance, and next one, displacement. What is distance and what is displacement? Distance means the total path length traveled by the body in a given time. This is called here the distance. The total path length traveled by the body. Here, this 4 meter he traveled, and this 3 meter also he traveled. So here in this example, what is the distance traveled means the total path length means 4 meter plus 3 meter is equal to 7 meters. 7 meters. So here in this particular case, what do you mean by displacement? Displacement means the shortest distance. The shortest path between initial and final point. Displacement means the shortest path between initial point and the final points. This is the And to find out to draw the shortest distance between any 2 points, simply connect them with a straight line. This straight line, this is the shortest path. This is the initial point and this is the final point. This is the shortest path. So here how to find out, and it seems a right angle triangle. In this right angle triangle, this is the hypotenuse. So we have a Pythagoras theorem. Hypotenuse whole square is equal to side square plus side square. This is plus. This is hypotenuse. This is I want. Let us say displacement d is d square. D displacement is the d, and the side square, this is 4 square plus this is 3 square. So d is equal to root over 4 square plus 3 square, and this is 25. 16 plus 9, 25, and d is equal to 5 meter. Okay, this is d is equal to 5 meter. This is the displacement, and in this example distance is 7 meters and displacement is the 5 meters. Okay, I'll tell you one more example also. So by learning many examples you can easily understand what is displacement and what is distance, but here I wrote the definitions. The similarity, it is distance and displacement both are measured by the same unit, that is a meter. The assigned for the distance and displacement is the meter. SI unit for distance, displacement is meter. Meter have two spellings, METER and METRE. Both are correct only. Okay, no problem. Suppose if you want to indicate with a single letter, you can indicate with the letter M only. Okay. And suppose have you seen Olympic running race? I think so. Suppose if it is a 200 meter, and here an athlete starts his race. Once one round if he completed, that is the completion of 200 meter. Let us say this is a, I'm taking an example. Let us say this total, it is 200 meter. So all will start here. So who I mean who reached this in very less time, that one is the winner. So here 200 meter, this is one. So here from here to here, so here in this particular case, distance means the by the definition the total path traveled by the body. This is the 200 meter. Displacement, this is the shortest distance between initial point and the final point, and this is the initial point and this is the final point, and the shortest distance are and the initial point and final point both are same only, they are coinciding. That means there is no distance at all. That means both are at the same point, means displacement is 0 meters. And previously in the previous example we got distance as 7 meters and displacement as 5 meters. And this example we got distance is equal to 200 meters, displacement is 0 meters. I know very well about Usain Bolt. Who is that Usain Bolt? He's a sprinter. So in Olympics he got many more gold medals. The fastest athlete. So here this is 100-meter running race. This is a straight path, you may have seen in TVs also. This is a 100 meter. So this is a straight line, and this is 100 meters. So in this particular case, distance is the total path length, means from here to here. Displacement is also 100 meters. Same thing. So in the first example, Distance is 7 meters and displacement is 5 meters. And second example, distance is 200 meter, displacement is 0. So you may have doubt that if displacement is 0, distance is still a non-zero value. So that means it has some numerical value, means yes, it is there. This is the example. Here displacement is 0 but distance is 200 meters. So they may ask so many questions like this. So here this is 200 meters. For 400-meter running race, Usain Bolt has completed 400-meter running race. 400 meters. That means two times he has to run. Two times he has to cover this distance. So in this particular case, distance is two times he is covering. So this is 400 meter. What about displacement? Still it is 0 only. Whatever may be the number of rounds, it is 0 only. Okay. And like this we have to find out in some cases, in some typical cases, they may give here the radius of this one. It is like 10 meters. This circle is having radius 10 meters. So in this particular case, for one complete round, they may ask to find out distance. What is distance? So this the formula, it is 2 pi r, circumference of this one, the formula. So 2 into 22 by 7 into r value how much? 10 meters. So you calculate this one. Okay. So here so what about displacement? It is 0 only. Okay. In some cases they may give diameter. So if diameter is given, diameter means from this point to this point. If it is 50 meters, and take radius as the diameter by 25 meters. Like that we have to work on this one. And this is about distance and displacement. And next, without wasting a single minute, we will go to next one, speed and velocity. Average speed and average velocity. And suppose we know that a particular body is moving, here it is, from here to here, and suppose you are traveling from Arakonam to Chennai, and it has taken like 1 hour time. 1 hour it has taken, like 60 minutes. Convert into seconds. 1 minute is 60 seconds. This is 3600 seconds. And from Arakonam to Chennai, let us say this is 100 kilometer. So for example, I am saying here it is 100 kilometer. I had not measured actually. It's like 80 or 90 or something. For the sake of easier calculation, here I am taking this is 100 kilometer. I know in this particular case, with how much of speed you have traveled from Arakonam to Chennai. Suppose if you travel with the same speed, the formula, it is average speed. Distance traveled by time taken. Distance traveled by time taken here. This is the distance traveled, how much? 100 kilometer by time taken, how much? 1 hour. So this is 1000 kilometer per 100 kilometer. 100 kilometer per hour. With this much of speed you have traveled, this is your average speed. So in this particular case, you have traveled with the same speed, constant speed. Okay. And here also we can define what is average velocity. The formula, it is displacement covered by time taken. And you may have a straight path. For example, from Arakonam to, this is all example, these are imaginary, don't argue with me. This road is not straight, like this. Okay, this is all I am taking an example. Suppose if you have traveled like this, from Arakonam to Chennai, and let us say this is something like 80 kilometer, and this is like 50 kilometer. So in this particular case, they may ask to calculate average speed and average velocity. So in this particular case, average speed means distance traveled by time taken. Distance traveled means 80 plus 50. How much it will be? 130. How much time it has taken? 1 hour. So this is 130 kilometer per hour. Average velocity, displacement. This is the displacement here. The shortest path between initial point and the final point. This is 100 kilometer by 1 hour. This is 100 kilometer per hour. This is the difference between average speed and average velocity. Suppose if you observe this formula, the units will be distance is measured in meters and time taken is measured in seconds. This is SI unit. This is SI unit. And displacement is measured in meters, and this is, that means average speed and average velocity both are having same SI units. SI units are same for average speed and average velocity, and that is meter per second. And I told you distance and displacement both are having same units. And what is the relation between distance and displacement? Sorry. What is the relation between displacement and distance? In the examples, I given 3 examples. In the 3 examples, if you observe, the first example distance is 7 meters and displacement is 5 meters, and the second example distance is like 200 meter and displacement is 0. In the third example, that is 100-meter running race, distance is 100 meters, displacement also 100 meters. So here if you see this one, distance is always greater than displacement, and in some cases in straight line motion only, in this particular case only distance and displacement both are same. Like this 100-meter running race, straight line, the athlete has ran, participated in a competition. So relation between distance and, if the, so if anybody is saying that distance is greater than displacement, displacement is greater than distance, that is a wrong statement. So in small MCQs, multiple choice questions, they may ask this one, so that is not a correct one. Okay, this is all about introduction of the motion, and probably in the next class we will go with uniform motion and non-uniform motions. Uniform